is what? Is in the what? Our next focus now is what? In the execution of the command. All right. So then I know you are probably like, why don't we look through the directory to find the executable file? Because that's what we said first before executing the command. And that is a good question. Good. That is what we are about to do. So basically it's the same thing. So yes, we are about to execute our program. So what you want, make sure that the how do we say, the operation you're performing on a what, on the tokenized string, on the token is what, is right when what, token is not equal to now in this statement, right? So let's get on with it. So I said that before we execute a program, there is something we need to do. Who can help us? Before we execute it, there's something we need to do, which is not looping through. It's basically the same thing. So anyone?
Am I try?
Yes, please.
Um, does it have to do with getting the environment?
Okay, so that one too is there, getting the what, the environment, but that one will come later. So let me not just type it. So yes, thank you very much. We need to get the environment. Thank you very much. So most of you have forgotten. I was explaining the last time about processes. Guys, please, you join. You started this thing from the start. Please, can you mute your microphone? You're done talking. So I explained processes that your executable program needs to run in a different process. You don't need it to run with the same process your shell is running. That's when I explained fork, where I explained exec v and then wait. And then it seems most of us have even forgotten that our program needs to be what? Forked. So this is where we want to fork the what? A different process and execute our command what? In. If you don't know what the fork is, why we are running our program in a different process, please go back to the other sections and then try to understand. So we are good to go. So probably P, yes, because you will return what? A process ID. So this is where you want to, let me, the comments are a lot. So this is where you want to fork. So that in case you come another time, you can know what you are doing. This is where to what? To fork. So we would want to return the what, the process ID. I explained that the fork returns what, the process ID. So we fork here. Why is this thing like this? So we fork here, and then let me not forget my colon before we move on. So guys, if there is, I always say we have to check the exceptions first or the edge cases. What if our fork fails? What do we want to do? We want to print that if what, fork, or no, we returned it to PID. So if PID, if the process ID, guys, what value does the fork returns when it fails? What I did as a process? What does the process ID return when the fork fails? Or what does the fork return when it fails?
-1.
-1. Please. So if the fork fails, it returns -1, right? I'm a bit confused. Is it one or -1? So if
Yes, it's -1.
yes,
Yes, it's
thank you
minus
-1.
one.
guys. You always have to help me because I mostly get confused when I'm on the PC. The tension is high. So thank you very much. So we want to check that if it returns -1, then we can see that what, our forking what, failed. So basically, this is what we want to do. So we want to print to the screen that what, our fork failed, and then we want to return -1 for what, error. Always remember -1 or non what, or non zero. What was the other one? It's either it's -1 or what. Someone should please help us. It can be, it doesn't, okay. No, negative integer. No, negative integer is for what? It's for success. And then less than 0 has to do with what? Failed. So yes, if anyone will help us, then let's see. This is what we are going to do. Else if. All right, you want to write an else if statement that in case the process ID is not less than 1, right? It is not, is is equal to less than 1, let's say, yeah, in case what our process ID is equal to -1, then we want to what print that what fork failed. Else, if it is not equal to -1, what do we want to do? So we understand that when it returns, if the fork process is equal to 0, then we can say that what it is a child process. So let's write a statement that else if fork, okay, is what equal to, is it 0? Yes. If fork is equal to 0, then we want to what say that what this is the child process. So let's add a comment there. This is the one, the child process. Let me bring it up for you to follow. So, guys, pay attention. Whenever we use fork and it returns what 0, then it means a child process has been created. And it is in this process we want to what execute our program. Nowhere else. If it is anything other than that, then it is the parent process, and our parent process belongs to what? The shell, the Almighty. We don't want to do anything else. Please take note. It's very necessary because this morning when I started building it, you might find problem with something like an infinite loop, right? So what happens is that if you don't take good, how do you say, if you are not able to handle the fork very well, what is happening is that you are going to have processes crashing or another process running infinitely without a stop. So I used about 15 minutes to solve this bug. So let me say it again. Take good note of what. After you fork the process, everything that happens, take very good note of it. So we are good to go. So this is the child process, and this is where we are going to what? Execute our program. So we can say that in the execution of our program, okay, what do you suggest? We must have our what? Our command path. And please, if you are not saying anything, you would want to mute your microphone. There is someone who is very busy with their notes, and then it kind of interrupts. So yes, so this is the child process. What are we doing in the child process? This is like a whole program on its own. So you want to start declaring. Good. So we need to declare.
Sorry, I have a question.
Okay, your question.
The first if statement came with PID, while the second is now with fork. Can you
Thank
please explain?
you very much. Thank you very much. Okay. God bless you. It is PID we are concerned about. Right. Hey,
Okay, okay.
thank you very much. God bless you. So it is a PID we are what concerned about, not the what the fuck function. Good. I always forget I returned it to what PID. Right. So it's PID we always have to what to use in place of what the fuck. So if our process ID is equal to 0, then it is what? A child process. Thank you very much. So let's go on. This is a whole new program on its own. So for now, just forget about everything we've written so far. And this is a program on its own. So what we want to do is let's start what? Running ls. Right. So in order to handle ls, there are some things we need to know. We need to check for path. That is what you're going to use to loop through. So we need to check for what? The path, right? And then after we check for the path, so we basically need a function to what? To check for the path. We will need a function to check for the path. But guys, please spare me. We will implement this function afterwards because I don't want you to confuse others. This function that we use to check for path, let's call for a function we have not defined. I know, right? But either ways, let's call for it. We'll use it. Don't worry. We will implement it. So we want to make sure we have what? A function that what checks for path. Okay. So even before that, we would want to assume we have. So let's just start. So this is what command path. Know that this variable is what command path. I don't have any other better name than that, but know that whenever you see CMD is the path. So it's basically what the path of what LS. And we as of now, if you are here, you already know what the path of LS is, right? We all know the path of LS. Right? It's been okay. Okay. So I think this is also a reason for my bag in the morning. But either ways, we'll debug it today before we all leave here because we all need our shell to what to work. So yes, so I think that's also part. By the way, let's go on. So the command part is basically where we can find the command. And here we know that it can be found in the what? The user bin. Oh, is it user bin? Let me confirm. Is it just bin or user bin? If it's just bin, it works. But bin. But what about user bin? We are all learning here. I think user bin should also work. So let's say okay, yes. But I think the user bin has to do with users, right? Just users. So we'll find out the difference later, but they are basically the same. But what we want to focus on more is what just being ls or what ls. So we need to write a function that will what automatically do this for us without have us what manually going through everything here, all directories. Imagine that your code has to what go through everywhere. Like let's go back to home. So let's say your code has to what the root. Sorry, your code has to what search everywhere. It has to search all of here and go and see. Let's say it first has to check whether user and it will go. Does user have ls? Yeah, no. They need to go back again. Like that is very tedious. So we need a function for that. That is why we need what we will need a function to check for what the path. So we'll implement it. Don't worry. So let's come back to our code. So let's say so our function name. What should we use for our function name? Let me ask. Since it's a brainstorming class, what should we use for our function? The function that will check for path. Anyone? We need a function name, please, to check for path. Just the name. I mean, naming of functions is not that hard, right? I mean, for software engineers. Hello, guys.
Can we use path check?
Path check. Okay. Anyone else? Anyone else? So yes, basically we can use path check. Thank, thank you very much. So let's use path check. Okay. And please, if you are done talking, thank you very much. Mute yourself. So, is anyone having a question? Please talk. So we want to use path check. Okay. And then what this function will be doing is that it will take the token as what? As what? This is always confused. Parameters and arguments. So yes, there is difference. Parameters. Okay, and arguments. So it takes the token as what? As an argument. Alright. So parameters are basically the placeholders. And then arguments are what? The value. Yes. So let's say arguments are what? The values. There is difference, guys. Don't miss them. And then parameters has to do with what? The placeholder. So in our get line function, we could have said, let me exit here. In our get line function, we could have said these are what? These are basically parameters. And then the arguments are what? The values that we place there. So this it takes token as what? As an argument, right? And then so this token here. The reason why we are giving it token is because token is what contains the users. Don't forget the users input. That is what you are going to use to search through. So let's assume we have what a function called what check path. Assume and it's in work. Assume we have a function called a function. Let's just say assuming we have a function to find the command path. You can locally use get path. That is also a very nice name. I think that's what I used in the morning. You assume you have a function to find what the commands path. Get path is also a very nice name, but let's use path check. Good. So we assume we have a function to find, right? So yeah, so guys, don't worry about this line of code yet. We will implement this function later. But for now, let's try and work on what our child process. So yes, so after that, what we want to do is that we want to check if command part contains something else. If not, okay. So if command part, what will it be? Command part is what? Guys, command part is what? It's a pointer. Nice. It's a pointer. Wow. So it should be a pointer, please. So if it's equal to now, if command part is equal to now, then it means what? It is a pointer with no what? No value. So then we want to say something like we were not able to, or we're not able to find a command, or let's say command not found. So always check for edge cases. In case you are not able to what? Oh, okay, 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 okay. So I think this one also gave me a bug in the morning. So yes, pay attention. So you want to say command not found. Good. So we want to print command not found. Let's return something. Should we return something? No. If command is not found, we want to exit the program. Right? We want to exit this particular program. And we know that we are in a different program now. I said it. We are in the what? LS or the command program. So we want to exit it. Exit with code one. For now, don't worry, we'll do all the conventions. Don't worry, for now, just exit with code one. Right. So we can say to say that what code one means we can say that it's what we exited successfully, or I don't know. No, it exited with an error, right? Because command was not found. So I want to say we are using exit. So please, if you are not able to, in your implementations, if you are not able to what find what the command, please you would want to exit with one for now. If there is any way we can also exit, we will talk about it. Time. Let me not talk plenty. So should I take questions? Which we should move on. After checking for this, we assume you have a function code. So if this is a child process, so after getting what, after finding the program, what do we want to do with the program? We executed what the exec v. Good. We execute the program now with what exec v. We execute the program now with what exec v. Good. We've come very far. Wow. Though it's not a lot. So how do we use the exec v, guys? The exec v. So we want to use exec v to execute it. Hello, guys. In my early discoveries, I discovered that we can actually use exec vp to execute the new program, which was nice. But the exec v gives us access. It gives us control over what we actually want to do. So the exec v. Anyone to help us? How does the exec v work? What does it take? You can use about 1 minute to tell us how the exec view is going to work. If you join the sections, then you know. Let's help. Anyone? So should we assume no one knows how to use exec v?
Okay, can I
I
say
think
something?
Okay. Why do you guys always make it hard for me to get you? Okay, so you can talk. Please say something. Don't worry, say anything.
So, basically, I think the exec v has a signature. It takes int exec v, and then in
Exec v. And then
yeah, yeah, constant character.
constant character. So how will we write a constant character? A constant character like this. Hey. Please a moment. Please a moment.
Yeah, yeah, constant card. That's fine. No, then the part name, yeah.
So sorry, guys. I had a call. So please, someone was talking. Sorry about that. Please, let me put my phone on charge. Yes, you are listening. So constant
Yes,
like this, right?
yes.
And so what name do we give to the string or the constant character? Pointer. A pointer to a constant character. I've actually forgotten how exactly works. So please continue.
Can you hear me?
Yes, we can hear you.
Okay, so then the part name, a pointer to the part name, yes, in that format.
Mm-hmm.
Comma, character, just car.
Mm-hmm.
Pointer to the constant argv.
So a constant what agv or how do they like this?
It points
Okay,
to
no
the constant.
and add the asterisks there.
So wherever so which one does it point to? Is it the what? The character or the agv?
It points to the argv.
Okay. So like this. Good. Basically like
No,
this.
no. Take it to the constant. Sorry.
Okay. Thank you very much. So please, is that all?
No, that's not all.
Okay, please, guide us through.
So yeah, you go to the after the comma, you just add car, the pointer to constant MVP, ENVP.
Constant ENVP.
Yeah.
Okay. So do you all
So
agree?
that's sure.
The ENVP is an array.
Okay. Thank you. Wow. 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 So thank you all very much. Thank you all very much. So let's move on. It's an array, right? Okay. So let's move on. What we want to do next is use the exact v to what? To so please, those who don't know it, VS Code gives you what actually it is. So this is it, right? So this is it. Good. So we have it here. Good. So let's continue. In the use of exec v, okay, this is what we are going to do. The first of all, we are going to find the path name as she said. So first of all, we pass the path name to it, right? Which is what? The command path, right? Which is the command path. And then we want to, okay, to pass what next do we pass to it? The constant okay. So which in this sense is what? Our token. Oh, okay. So then I think this is also part of the reason that my code was having bugs. But let's implement it this way. Good. We've obviously not done a lot of things like we've declared our token here, but we declared it as what? As a string. And then so we'll get back to you. Don't worry. So for now, guys, let's stick to this. Okay, so what we want to do is first we want to do this, and then we want to pass this is what? The environment, right? So there is a variable, there is a variable in C. For now, let's use that. Okay, so it is a global variable. Okay, then it holds the environment variables. Okay, so this way the new program will have what? Access to the environment variables. And that name of that what? Global variable is what? Environ. So for now, let's use this. We are good to go. So please, does this make sense? Is anyone confused? Does anyone think we are doing something wrong? Hello. Okay, so that means what? We are good to go. Let's write our codes and what? Find our bugs later. So the next thing is you want to check for edge cases if what? The exact view what? Fails. So you want to write a statement for it that in case the exec v fails, always make sure you check what the edge cases. So let me write it in the form of um, a comment. Check if exec v what fails. So you would have something like if. So this whole thing we pass onto it. We have to equate it to if exec v fails, what does it return? So we have to pass this whole thing. I think is what do we have here? Command path. Let me just copy it. I think the way I copied it. Copy. Oh, okay. It will not work that way unless I copy it manually. Sorry. And then we put this in what our if statement. So we basically want to check, okay, that if the exec v, okay, is equal to -1, then what do we want to do? If exec v is equal to -1, what do we want to do? We want to print to the screen an error. Basically, that's what we have been doing all this while, right? So we want to print something like failed. Oh, okay. So it means my program was executing in the morning because it did not print this error. So the problem was definitely with the function failed to execute the program. Or basically, yes, I think this error code is failed to execute the program. So if we fail to execute a program, guys, take note of something. If you fail to what execute a program, it's a very essential matter, right? Because basically that's what we are trying to do, and we have failed. So let me show you something. We want to exit, right? I should have even asked this. We want to exit, right? So by this time, we want to exit with failure. I asked you to check. I sent you guys the exit conventions. Please don't be confused because I sent it to you to read through. So if you know, even the name itself says, if you read through what I sent, or if you read the resource and then you checked and searched, you know that's what this basically is trying to imply. That's what to indicate the command could not be executed, right? So the command could not be what executed, right? So else, that is, if by the grace of God our program um actually executed, right? So I think we've come a long way. We can take some time to check what we have done. Right. So um why do I feel like I'm doing something wrong here? Okay, guys, we are good to go. We are good to go. So at this moment, let me ask any questions, anyone confused? Can we move on? The next thing we want to do is we want to write the functions that will look through to find what? To find our command. So any question, any question, anyone confused? Implement the what? What was the name she gave? Please, the name, implement um the check path or path check function, right? So we want to write a function that will check for what? The path, right? So implementing the path check function, right? So yes, font family, no, you be here for now. So I want to write, so we will Now implement a function to what? Look through, no, just to say to find the command path. Guys, we are moving on to a next section. So if you don't understand anything, please let me know. Thank you. So we basically want to implement this what? Let me push so that my works will be saved. So use exec to execute. Let me push. So basically, what we're about to do next, the place is very silent. I hope you guys are around. I hope I'm still audible. Can you hear me?
Yes, yes.
Yes,
So the
yes.
next thing we want to do is okay. Thank you guys very much. The next thing we want to do is we want to write the function for the function called what path check to check through what to check through. Let me explain myself again so no one gets confused because we are writing it in a different file to make the code more readable and accessible. So we will not manually what check through here to find where our command is. We want to write a function to what do that for us. And then we came up with what the path check to do that work for us. So please let's do that in what a different file. Let's call it path or I think how did I name that one? Check path here basically or get path. Yeah, let me use the function get path. Okay, so get path.c. This is where we are going to what define our function, right? Right. So we want to come up with a function that will look through the directories and give us what the path of the command the user entered. If it's ls, if it's make directory, you want to check if it's the same thing. Any ideas? How are you going to achieve that? Come on, guys, let's brainstorm. How are you going to achieve that? Anyone? How do you think we'll be able to look through the directories to find what the file we are looking for? Any ideas? It doesn't have to be a code, it just needs to be an idea, and then we'll take it from there.
Hello.
Hi.
I think the first thing you need to do is check the path, like echo path to check.
Am I the only one? It's like I can't hear him well. I am. Hello. Can you come? Can you come again?
Hello, can you hear me better now?
Yes, it's better.
Okay, sorry, it was my AirPods.
No problem.
So I was saying I think the first thing we need to do is like check the path, like the direction of the executables.
Check the direction.
Like I think we need to like echo path or something to like check where those um inbuilt commands like ls blah 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 stuff like that where they belong to us. I don't know if you understand what I'm
Oh,
trying to say.
okay. So I should do something like this echo path. Okay.
The
Um.
path is going to have like the dollar sign that will.
Oh, okay. 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 I get what you mean. So please, what else? Just this. Oh, okay.
Yes,
Okay.
I don't know if this makes sense. It's just something I
Mm,
discovered when I was.
mm. So thank you very much for the discovery. So if there is one thing we will realize, this is what our path. So how are you going to work on this path? So now the question is, so thank you very much. So first of all, we check for the path with what, and then it helped because if you know this, it changes a lot of things. So check the path, right? With what you want to check for the path with what echo and dollar sign and path, no path, right? so that you see all the what the where the various this ones are, right? So this is the various directories we are having. If you pay attention closely, we now have what? A full string. True or false?
True, very true.
Very true. Thank you. So what do you think we can do from here? Because we now know our path. It's a full string. So what are we going to do? It's a full string, but you realize that it's a bit there is some bit of differences. Like if you know what I mean, what do we do with this string? Hmm? Yes, you can talk. If you raise your hand, you can talk.
Okay, so from the little I know, uh, the path, as you said, is a string, but then it contains several directories that are separated by a colon. So after each colon in the path directory, sorry, in the path string is an actual directory in our shell.
Mhm.
So we could tokenize this full string using the colon as a delimiter.
Wow.
Yes.
Wow. Yes. Yes. Basically, yes. Yes. Thank you very much. Thank you very much. God really, really bless. So, as you can see, we have a string. Okay, and we know that this string contains different directories, right? Different paths like directory too, because we know that this is a full path on its own. This is a full path on its own, and then the only thing separating them is what the what column. So I forgot to say something. The delim, I think I said it. The delim is the what is the separator, basically. What you can use to separate what the strings, right? So it means from here we have our delimiter, delim. So let me undo this and try and get it here. It still doesn't fit. Let me try and bring it here. I want it to be full so that uh others can see it. Either ways, what you are trying to say that what this is what. So we know that the part, right? It's a full string, right? So basically, from the idea we know about tokenizing from strings, if we want to get the individual, we will have to what tokenize them. So we can what tokenize this, tokenize this to what to get the separate. Guys, please be with me and help us write this thing because this is where the challenge also starts. You can tokenize this to get a separate what parts, right? Of yeah, basically directories. Uh-huh. So using what string talk. So if you are watching, then you know that our next step is to what tokenize this full path using what colon as a delimiter. Good. So how do we do that? Let's come back to the code. We have our file here. Don't forget we have our header file, include our main.h, and then in our main dot in this we can let's write something so that anyone comes here knows what they are doing. So basically, we want to write something like okay, this basically contains the path to search. Yes, this this basically contains because of time, I have to be fast the path to search. So let's get this basically good. So this basically contains, you realize I like saying basically a lot. So yes, so what we want to do first, all right? So in our function declaration, what are we passing to it? We're passing token. Path check is what we're passing token to it, which was a very nice implementation. So what we want today is to um, let's get called we call the function what's the name of the function again? It's not easy.
Path check.
Path check, right? So we have path check. and then path check is taking what? So this is what you are going to do, guys. If you are, I don't have to explain these things, but if you like, if you've come all this far to build your simple shoe, you know what we are trying to do, right? So this is basically like a pointer, right? A pointer that points to the command. But know that for now, this is what this is. How what did I say? It is, it takes the tokenize. So let's say this command, this takes, because of time, that's why I'm trying to be fast without explaining. But this basically takes the what? It takes the tokenized string. Remember we tokenize a string, right? We all remember we tokenize a string. We tokenize the token. Yeah, we have a token. So this takes the what? Tokenized string. The tokenized string. Tokenized. This takes the tokenized string, right? And as argument, I want everyone to be able to understand what we are trying to do. The reason why this red line is following me is probably because I didn't what? Okay, okay. Okay, it's because I've not brought anything to define it. So as argument and call set command. So I think this is enough to explain it. This is to help anyone, okay, to help you understand that this command we have here is basically a pointer to what? Our token, the token we have here, right? Is that even the right thing to do in the first place? um, why would why would yes, 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 that's the right thing to do, because we want to check the input, right? We want to check the input. We take the token here, we pass it to this function, path check, and then path takes the user input and then loops through what? The directories to find it. So basically, I think this is correct. This is supposed to be. Guys, if I'm making a mistake anyway, you bring my attention to it, because mostly here it is what? Tensed. So what this is what you want to do. First of all, let's say that let's declare a variable called path, okay, which is a pointer to the what? A path. Our path, and then we use get env to what? To get the what? What do we use get env to get, guys? Hello? Get env. Is it new? Anyone? What do we use get env for? Wow. So basically no one knows what we use get env for. Guys,
Is it to get the current environment?
Yeah.
do you all agree? To get the current environment. Thank you very much. So yes, to get the environment variables in what? Code. Now what? Current path. So I feel like I'm losing something here. So we have our path now. Okay. Okay, sure. So let's continue. If there is anything, we'll probably find the error here and we'll fix it. Good. So if we run the code now, you realize that I think let's run it and see what you've done so far. The only problem will get to be from um initialize of car from integer. So we'll come back to this. Yes, implicit declaration of what? Path check. And that is what we are what? Doing now. So let's focus on that. We have an error in our path. So this is what we want to do, right? So let's create another one. This is what? A copy of what? The path, right? So no one is going to tell me that something is wrong. We should move on. Good. We will move on. So okay, string duplicate. We want what this is what I want us to do. We are going to duplicate, okay, we are going to duplicate our path, right? So that the reason we are doing this is that we don't want to modify the original environment variables, right? We don't want to modify it directly. So we want to create a copy and then we want to what, store it in another what variable called what path copy. Is anyone having anything to say? Then please mute your microphone. So we would want to say we don't want to not to modify the original um the original environment variable that we'll be getting. Yes. So let's move on. That is why. So after declaring our variables, the next thing we want to do is what we want to do our string token. Yes, the tokenization. Tokenization. This spelling always gets me. Tokenization, right? So what we want to do is that we want to tokenize it. So let's say we'll create a loop. All right. So first of all, let's tokenize it before so that the loop is what is going to iterate through what everything to check. So let's create a variable called directory. This is where you are going to store the path in all. After tokenizing it, okay, we are going to store each token into. So let's string tokenize what our path, right? We have a copy of it. So we are tokenizing this, which is what get this. So yes, path copy, right? No, we need to set a delimiter. What can we use as the delimiter? Yes, the column, right? So we need to add a delimiter, which is what the colon. I hope everyone understands why we are using what colon as what a delimiter. If you don't understand, please ask and we will explain to you. Why am I having error with string token here? So basically, yes, we are tokenizing what our path, and then we will create a loop to iterate through with what we have so far. I think I'm getting tired. Create a loop to iterate, create a loop to iterate, and what can we say? Yes. Can I say to concatenate? No, let's just say create a loop to iterate. Right. So what this loop is going to do is that it's basically going to what? I think I've already explained this. When you're using string token, you need to have a loop to what iterate through. So let's say if that is not equal to now, what do you want to do? So whilst the directory is not now, okay, while the directory is not now, what we want to do, this is the first assumption we can make, that while the directory is not equal to now, you can say car. Guys, what do you want to do? Help me, I'm tired. Guys, what do you want to do? So the recorded section is taking the string, is taking a token. It brings the token here. It works. This takes the token as an argument and then what calls its command not to modify the original string variable. So we create a loop to iterate. So we need a pointer. Okay, we need a pointer. And then use a one. So no, so we'll use full path rather. So full path will contain. So let's allocate memory space for it. So that is the string length. Let me explain what is happening here before I continue. So this is what is happening. We are using string duplicate, okay, to take a copy, right, of the path, right? And then what we are doing is that basically we are allocating memory dynamically for what? A full string, right? That is the string we are going to be taking. We are allocating a memory space for it. And then that is why I have malloc here and I'm trying to allocate memory space for what? The full path, right? And then the size of the allocation is how we are going to do it. It is going to be calculated. So we know what string length does, right? It returns the length of a string. You might want to write your own what string length what function. But for now, since time is not on our side, let's use this. So what we want to do is we want to check the string length of the directory, and then we basically want to what? Add allocate memory space to for our command, which is what the token that we have. So let's say command, and then we want to add an extra two space, an extra two, because we need to have space for what? Colon, and who can tell me what the second thing is? Hello guys, because we need to have space. Okay, for let's say this thing, this this forward slash, okay, this forward slash, we need to have space for it. And then in situations where we have something like, let's say, um a null character, this is a string, so it obviously have a null character. So yes, so we are basically saving space for this slash. We will use it to what? To get it, and we are saving space for this forward slash and what? A null character, which is what? Which indicates the end of the string. So yes, so I think I'm on the right track. So yes, basically that is what we are doing. So let's move on. We would want to, should we use, we would want to, what do you want to do? We would want to format it. So after getting this string, okay, okay, we would want to format it. Before anything else, let me try and print. I don't know if I can do that. Let me try and print what we can. In the tokenization, we can print, right? So let's print. No, let's use. Let me do my thing. So sprint f. Okay, so sprint f is basically like what is used to format strings, right? And this is how we are going to format it. First, we are going to format the full path we have, right? And then we say that this full path is going to be something like, let's say, um, it's going to be a string, right? It's going to be a string separated by what? A forward slash, and then another string. Because if you have bin ls, the only thing that separates the bin from the ls is what? The forward slash. Yes. So basically, yes, we want to have something like this. And we want to say that what? Directory. This is the directory. And this is what? The command. We want to say that what? There are actually two strings, which is what? The command and the directory. And this is how we want to separate them. The directory goes here as the first string, and what? The command goes here as a second string. And then these two make up what? The full path. Good. So I think we are good to go. We are good to go. So guys, at this moment, is anyone confused? Does anyone have any question, contribution? No one wants to say anything before we move on? Any question? I'm really getting tired. Good. So
Are we allowed to use printf?
please say,
Are we allowed to use printf as printf?
are we allowed to use printf? Printf, guys, are we allowed to use printf?
I don't
I
think so.
think
Let
we
me
are.
confirm.
I didn't get a response for. Should we use printf?
I think we are allowed to.
Okay.
Mm,
So we want to format our string. All right. So this is what the function I know I can use to what? Format my string with as two strings, right? And then use the what? Um, how do we say it? The forward slash to what? Format it. So if anyone has any other means we can achieve that, you can share it with us. We want to basically what we want to do is that we want to be able to tell between the directory and the command. We want to tell that what the first part of what of the string of this. If you have something like this, then ls. you have something like this, then ls, right? Basically want to say that what this is what the directory, and this is what the command. Because if we enter cd, let me go into bin. So if you enter here, this is where we'll find ls, right? So that's what we are basically doing, and I don't have any other means I can use to achieve that except with sprintf. But if we run the als test suite and we have a problem with it, then we rely on other what means. So great, we are good to go. So what do we do next? We have the string, we have our command. Okay, we have our command. So let's say basically we have found what we are looking for. What do we do with it? So from here with the command, after getting everything, after getting the we have our path, we have everything. What this function should do is that what it should check if what our file is what executable. And then if you want to check if our file is executable, this is to help us keep the files in which we don't have the right permissions to execute, or files which are not what executable. And then in the last meeting, I explained how we can be able to achieve that. True or false? True or false? How do we check if a file is executable?
True.
Yes? Yes, someone was talking. Which function do we use to check if a file is executable? Hello, software engineers.
Access.
Come again.
I think it's access.
Okay. So the last section we talked about access, right? So after finding thank you very much. Thank you. So thank you very much. Oh. So we want to check, okay, if the file we are what executing is what executable. So you want to, and you know what you want to use the access on. So if, oh, okay, sorry, is it a command or full path? We basically put everything in the full path. I think that will give us a bag. So what are we checking? We are checking if what. Can a full path be executable? Yes, guys, I think so. Guys, can a full path be executable? Yes, basically yes. How come I've forgotten all of this? So a full path can be executable. So what we want to do is I want to check if what the full path is what executable. So let's pass full path rather to it. Good. So when we say that if the file is executable, what does it return? So first of all, we want to add the mode. In order to check if it's executable, I talked about the different modes. If you don't know them, you don't want to go back to what the recorded sections and know that s underscore okay is used to check if a file is what executable. And if it's executable, it returns what 0. So if full path is what executable, then what do we want to do? We want to and finally what execute whatever that we are having. So we can say um, I think I forgot to make mention of something. So we have a duplicated string. If it is executable, we don't need that again. So we want to free that. We don't need it again. So um we can free the path copy, right? Because we basically don't need that again. Is it path copy or what's the name? Yeah, path copy. And then we return something. What do we return? Guys, what do we return? We return the full path back to the program for the program so for exec to what execute it, right? But if it is not executable, what we want to do, we want to carry on and then forgotten. Okay, we want to we tokenize it here, right? So just like how we implemented this, after writing the statements for it, we want to iterate, we want to go back to the next token, which was what I think I did it here. Okay, I removed it. I removed it. The time we were printing it. So after tokenizing it, you want to what? Iterate with it by accessing the next element. So we basically want to do something like we first want to um let's free full path, because there is no need for full path again, because if it is not executable, then we just need to free it, and then let's iterate, right? So what was it? Was it string token path copy, right? But the last one is always what? And now, and then we set the delimiter for it, which is what? Our delimiter is the column. Great. So we have something like this. Good. So this is basically to iterate, or let's say proceed to the next directory. Want to proceed to the next directory. Wow, I'm very, very, very tired, and there is still a lot to do. So let's move on. Wow, we've come very far. So we want to proceed to the next directory if what? If that particular file is not what? Accessible, it's not executable, right? You want to proceed to the next, right? So after we are done with this, we need to, I think, let's go back again. What do we need to do? We need to free this. We duplicated this part copy. Yes, we freed it here, but we also need to free it here. So yes, we need to free part copy. Is it part check? No, it's part copy. We need to free part copy. Semicolon. And then so basically if the executable is no if no executable is found, then we can say that what we are returning and now. So if no executable is found, we return what? Now. So let's return it here. So the return now will be where? Here. Why do I always want to use cows for return? So we want to return and now, right? So I guess we are good to go. We are not all good to go, but we are good to go. So there are a lot of, I think, as I know, we have not been running our program. So meaning we have a lot of bugs to what? Fix. We have a lot of petty mistakes to check. So with that one, we would have to what? Use GCC. No, even before that, I think we are not done with this code. Hey, we are not done because we need to check for exit status and everything. We need to wait for. Okay, so basically, let me use this to demonstrate before we imply it. So this is what is going to happen. At the beginning of it, I said something like when you use a fork and then you don't use it appropriately. So one of the ways you are not going to use fork appropriately is what? Not letting the parent what process, which is what the shell, wait for the ls to what finish executing. So we can try it out and see what happens. So let's try and run our program at this point. Let's see our errors, our mistakes. Then so GCC, let me clear the screen. So I think I have my flags. Wait, all this I was using this to execute. Wow. It's GCC flags. We need to be very much conscious of what we are doing. So we basically want to execute every C here and then every find with C here and then give it a new name called show. Right. Oh, I also not even that plenty. So I think it's something we can fix. Good. So guys, we are having implicit declaration of function path check. What does it mean? What do we have to even after defining it, we have an implicit declaration. What could be the problem? I need your responses and contributions now. Okay. Hello.
We've not put the declaration in the main.h file.
Good, good. Good. So that is the problem with this, right? So you solved the our first back. We've not put the declaration in what our header file. Let's get it. Where are you? Where is it? Get part. Yes. So we need to have this declaration where very necessary in our header file. Where's our header file? Hey. Oh, okay. It's not easy. I'm very tired. So good. So thank you very much. You solved our first error. You have a second error to fix. Oh, really? It solved that. That's very nice. Thank you very much. So let's say this is what we've done. Okay, we've written a program that is command tokenizes it, executes it. So far, we've done all of this. Haven't we done all of this? We've done the executable for command to execute a command. Yes. And then I know that we are not done yet, but because after forking the child process, it needs to what? Wait for what? The parent needs to wait. They are not supposed to run together. So let's try. Let's use my system for the sake of this experiment to crash my system. So let's see. We are basically having two processes run. It will be very fun. Let's try it and see. So at this moment, our parent process is running, and then we forked and then we record for the child. Right, right. So this is what is going to happen when you don't, and I don't think there is an easy exit out of this. So I have hesitated. Also, I think when you call for fork and then you don't let the parent process, okay, wait for the forked process. What basically happens is you have something called an infinite loop, and that is what happens. So it goes on, the process continues to run and run and run and run, and then this is what happens. It's like having two instances of what a process running, and then the funny thing is, okay, the funny thing is, it doesn't even just end there. Let me run it again and see. So let's say I want to exit. So this is what it writes. Fork failed. Resource temporary hot unavailable. So if you have any error, if you catch yourself in an infinite loop, you have not used any while loop, but then this is happening, then it means you have to what, check your fork because your fork what it failed. So before we move on, any questions? Can we move on to implement or solve this bug? Any questions, any contributions? Are we doing something wrong? Apart from the fact that our parent process has to wait for what our child process. Is there anything else? Guys, let's brainstorm and come up with something. What are we doing wrong? From this bag, what do you think? What else do you think we are doing wrong? Okay, so listen. When you run ls, right? When you run ls, okay, are we supposed to get command not found? Are we supposed to get command not found? Okay, so Ryan, I have a question for you since no one asked the question.
No,
No, so what are we doing wrong? Cool. So what are you doing wrong that we are getting command not found? What are we doing wrong?
I think it's not like able to locate the path or something.
Okay, so that means it has not been able to locate the path. Wow, that is very nice. But so we'll get to that. That was that was the ultimate bug I was solving in the morning that made me late for the meeting. But either ways, our program is still supposed to work without this. So basically, let's try and implement what is happening next. So after calling fork, let's try and implement this. A moment. So yes, so this is what you want to do. Sorry. So let me write something for you to be able to understand what is going on here. So we called for fork, right? Creating two instances of a running program. Creating two instances, right, of a running program. And then after this, we didn't what? We didn't use the wait to for the parent for the parent to check the status, the exit status of the what of the fork. So what we are trying to do now is we are trying to what trying to use wait in our codes, right? If you focus very well, we don't have a while loop, a big while loop for all of this because mostly shell is what? Shell is a bit of, how do we say, it's a constant loop because shell doesn't end till you what? Let me use this to demonstrate why shell is in a loop. Let's say when I use exit, so this continues to give me responses. When I press and hold enter, this continues to what? Run in multiple times. And it doesn't end to you what? So you enter exit. That is when the loop ends. So it means that shell itself is what? A big while loop. We'll implement that because of time. Time always doesn't favor us, and I'm also tired. So we will come to all of that when you press exit, our program has exit. When you press control plus D, what happens? It's also exit, the same thing, right? So control plus D, that's, and I think in the last section I talked about signal handlings. So most of these things are signal, and then we handle interactive and non-interactive. But today is just what? Taking the user's input and what? Executing it. So let's move on. Let's implement the wait, right? So what we want to do is that, where do you think our weight will go? Where will our weight be? Guys,
In the parent process,
in the parent process, okay, okay. Anyone else? Anyone else?
Yeah. I mean, since the parent is going to wait until the child processes everything is done, yes, it should be in the parent process.
Okay, okay, okay. So basically, we are going to what? Implement the wait for the wait to finish for what? Our child process to be able to what? Finish. So let's try and implement that. Is anyone having anything else to say? What do we need? Is there, like, guys, we are missing something. We are going to write the weight in what? The parent process. Okay, okay. So where do we start? Where do we start?
Yeah.
Is that?
Can I try?
Yes, please, you can talk.
Okay, when you are using the if statement to execute the child process, I don't think we looked for the parent process. So you're supposed to like write an if statement that will check the parent
Wow,
process.
wow, wow. Thank you very much. Honestly, I really appreciate it. So yes, we need to check for a parent process. We need to write a statement to check for a parent process. So this is what? This is a fork failed. This is if the fork fails. This is if the fork returns for the child process. And then, so we need to write a statement. So when is what? When what what does fork return to indicate that what? We are now in the parent process. Let's brainstorm.
If
So yeah, if the return value of fork is greater than zero.
So want to say want to say else if, so basically if what? If the return status of fork is greater than zero, then it's what? Is that we are in the parent process, right? That is very true. So we want to write that here. So if the what? The return value, we said this in the previous sections. If you're not here, so if the return value of fork, right, is greater than zero, then we can say we are in the parent process. Then we are in the what? Parent process. Good. So let's leave this note down. So thank you very much. We can equally say else if, right, PID is equal to what? Zero. And then we have three returns, right? we have if the PID is equal to 0, if the PID is equal to -1, and if the PID is what? Greater than 0. So I don't think we need any statement because the last statement left is then eventually what? The parent. So we just write what? An else statement. So let's just say, where is this else statement? Wait, what is happening? I think I need to bring, I need to guard this, right? I need to bring this, right? No.
No, you are writing inside the child. So the
So I need,
curly braces of the child is on line 64.
oh, okay, 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 okay. Yes. So it's supposed to be here. So we can say else. Am I on the right track?
Yeah.
Thank you very much. That
Yes.
just confused me. Let me bring this down. So we can say else. So once we bring an else, we can say that what? We are in what? The parent process. So anything parent related should also go here. We are in the parent process. Right, right, right. So this is where we have to wait for the child. So let's say, I think with the BI is a bit no because of time. Let's leave the comments for now. So we want to say that what we want to use status to what check the what the waiting status to know what we can be able to return. So this is what we have to do. So we can declare a variable called status, which will be what the status of the parameter or the argument for the weight, right? We can declare something like this, and then we can say weight PID, right? So we will use the status. So we have the PID, and we are saying that we are taking the status of what the PID, and then the status, the address of the status, basically an ampersand. They confuse me. Yes. So this is how we will use the weight, and then we say that what. So, so if you learned about the conversions, I explained conversions. Yes. Let me just move. But let me say we will wait for we will wait for the what? The child. Right. So we are good to go. We've used wait. Now we want to check. We want to use conventions to check. Like let's say if the waiting status right returns an error. I always say that we need to make sure to check for exemptions. So in situations where um the PID, the process ID, the child returns, we want to be able to get that return like that and PID and then depend on that to know if our program was executed successfully or not. So we can what? We can continue. So we can write a statement like if I think in our resources we have something like this. Thank you. So with exited, right? Basically, what we are trying to do is that we want to add the exit status of it. Basically, that's what I want to say. So so let's pass the toss to it, right? In small. So we want to pass the toss to it, and then we want to say, okay. I think this one will confuse most people. Exited. Okay, with exited with. So this is basically like we're sending a signal. I think if I add another so it might confuse people. Let me just add it anyway. Time is almost up. When you get time, you go and let's say so is it another one. Good. So we've edited. Then we want to say status. So okay. So what does the weight return to indicate is so we want to say something like if it's not equal to 0, right? So if the weight if the status and then the status is not equal to 0. Oh, that's the mistake. This is status, not exited. So this is guys, a moment. This is status. But before that, let me talk to I'm coming a moment. Okay, sorry about that, guys. So let's move on. Where are we? So with our exit, right? So I think this is part of the reason why we were having this role. But let's see if it solves it. So we want to do exit status. Is there anything? Can anyone confirm for me? Am I doing the right thing? Can anyone confirm for me? So um okay, so let me confirm from here if I'm doing that. I don't want to make any mistakes for anyone to have any problem. So when we use the exit status, what else do we need? Do we need and let me confirm. Let me search moment. We are all students here learning. So is there anything like status here? We have exited, signaled, stopped. So if the status, if we exited with status, let me confirm.
Yes, there is we exit status.
So is okay, so is status, right? So yes, it's status. Okay, not knowing all this one, it was down there and I was finding difficult how to spell it. Thank you very much. So we W as it whatever it is, but basically this is what we are doing, right? Right. Wow. I'm lost in my program. Please don't be lost with me. Um so let me get back on track. So if it's equal to zero, then what are we printing? If it's not equal to zero, then what are we printing? Anyone?
We are not printing anything, but I think we will exit.
Yes, thank you.
We will
So
exit the program.
yes. So thank you very much. To be sure of the exit status for now, let's yes, she's right. You exit the program. So basically, this is what we want to do, right? We want to say that the child process, so that in order for us to see the ID, the particular ID is returned and everything. So let's say child process. So thank you very much. After here, we would want to what exit the program. So let's say exited with what? Exited with let's say it's exited with a non-zero, right? Just for clarity's sake, non non-zero integer if it's not equal to zero. So yeah, so then it means it's what? It's non-zero um status. And then let's print that. That's what the D there for is for the what? For the what? The process ID. So let's say with status, I think for now let me try and declare so I'll know the kind of placeholders to use. So we have PID here. We want to print our PID and we want to print our what? Our status. So we this the spelling of this so yes, basically the spelling of it is what gets me stuck sometimes.
Yeah, I think you can easily like keep it in mind by just saying, you see, it is W exit status, so you can like for easy reference can do like
Okay,
wait
W as
exit status. Then the wait is just W.
okay. Thank you very much. So basically I've gotten the right spelling now. Thank you very much. So we want to close and then so I don't know if this will work. Let's add a new line here. So yes, we've returned the words. Why is didn't I bring my column? Why is if expected? Okay,
We
then
are
it
using print
yes.
instead of printer.
Muted. Okay. Python will kill us. So so we are using guys, you're not allowed to use printers. So we are just using this to check the exit status so that we can easily debug our code if there is a need to. Right. So if you are following this thing very well, you will realize a lot of things. Let me bring this back. If you are following this thing, what you are doing very well, and then you follow through the life. sorry, the recorded section. If you're also following through the recorded section, and if you don't understand anything, you can just basically go back and then you understand what we are trying to do here. Good. So, because of time, I might not explain some things, but I realize that our code is not what it's not complete, and we are not done. So yes, shell is a lot, but basically this is what we are what doing. So if you are following very well, you realize that we need to what check for what. Okay, we check for our return. We need to free a lot of the stuff too. We need to free stuff like line, but we'll check all that when we are done. So don't worry, because line itself is taking data, and then we want to. And since we are tokenizing here, let's continue iterating through. I hope I'm very audible. Hello guys, am I audible?
Yes.
Yes.
Okay, thank you very much. So if you are following, you know why we have this here, because I explained to it that basically we want to move on to the next what input that the user what sends, like basically like whatever we have, right? So this is to indicate that there is a guide I'm missing here, or everything is okay, we are good to go. Okay, yes, it's in our while loop. It's in our while loop, right? So I was saying that we need to have a bigger while loop, right? So this wait status solves the problem of what our fork behaving this way. So we would want to say it's in a bigger while loop, but we will not implement that now, not to confuse anyone. If you don't understand anything, as of now, before we compile and run our code, let me ask, is anyone confused? Do you have any question? Are we doing something here you're not understanding? Please feel free. Anyone?
Can you explain the if statement after we used the wait lady?
The
And
if
then
statement
you
here.
used yes, yeah.
Okay. Please, can anyone explain to her what that if statement means?
What the what?
This if statement, where we waited for it, why did we print this statement? What does it mean? This one.
So in summary, if anything is successful, right, the status should be like zero. Okay. I think after the meeting, you can do like more research. But then for now, you can keep it in your mind that for successful
Hello. Guys, can you hear me?
like exits,
Okay.
it should be
Oh, we are not hearing.
what?
I can't hear her, but I can hear you.
Hello. I think it's her network. But can you guys hear me though?
Hello, please can you check the chat? I dropped a question.
Yes.
Okay, so someone also said you can check the chats. As definitely.
It's actually a question I dropped on the chat.
You have a question in the chat.
Yes.
Okay. What question is it? Oh, okay, okay, okay. Good. So thank you for that question. Any other question or any other thing else? Please, was hello, is Ami still here? Hello, Ami.
Hello.
Why
Sorry,
we are
my
not hearing
network,
you. Yes,
it
so
just took me out.
understand what this is.
Yeah. Yeah. So I can't really give a very clear explanation, but then for me, what I told myself is the exits, if an exit status is zero, right, then it is a successful something. But then if it is not zero, then it means there is something wrong somewhere. So we are going to exit with that particular status that we got that is not zero. But then there is more to that. It's just I don't have everything in my mind right now.
Okay, thank you very much.
All right, can I say something in respect to that too?
Yes, please.
All right. Well, as we just in addition to what you say, I believe it in C that exit code with zero actually means success. Just like most of the lower programming we do initially, we have exit code -1. It actually show that it's actually negative, but most of the time we can actually use any other number to represent failure. But mostly zero means success. So from the line of code, it shows that if it is not zero, definitely any other exit code it comes in with, it shows it's not a success, which means something is definitely wrong with the code, the output. I don't know. That's the little thing I just feel let me add up there.
Okay, so please, do you understand, or you are more confused? Do you understand what our friends are trying to say? Hello, am I audible?
Y- Yes.
Yes, we can hear you.
Okay, so please, if you are here, do you understand what they are trying to say?
Yes.
Okay, so let me touch on it. I think we've all done a good job explaining it very much. So let me touch on it. So you realize that okay, in the program you are writing, all right. So we use fork to call for what? A child process, right? So what this one does, the W exit status or wait exit status, okay, it checks if the process terminated what? Normally, like it terminated as expected. Normally, there was no interference. So I've explained that we running the program is what? It's an instance of a process, right? So we want to return that process what to the parent, and then we don't just want to return that status, the status to the parent. We want to add informations, right? So like let's say if we are at home, most of us from African homes we run errands, and then this is what happens from the African homes, when the parent sends you, right, when they give you information to go and do something, when they send you on an errand, they expect you to return with what? An information or whatever they are sending you. So if you get what you want to buy, return what you bought. If not, tell me why you didn't get it. So then, this is basically like the child telling the parent, okay, how he exited. And we know that if the child exited with zero, we know that zero means success. So if you brought the actual good your parents asked you to buy, then it means you successfully ran the errand. But if not, then it means that what there is something wrong. So tell us, why didn't you get what you went to buy? So that is what is returning. So if we don't get what we went to buy, then we are just telling the parent that what we hesitated. This is the reason why we came back without the goods or stuff you sent to us. So basically, that's what we are using this statement to check. We want to be able to write something to what to the parent process that what this is what happened, and if not, then if something interrupted it, so that means if the child did not what return the goods, then this is what we are telling that this is the reason why the child did not what return. That is why I suggested that we print something to indicate why the child was not able to buy the item the parents sent him to buy. Right. So so basically like it checks if the process terminated normally. So that is it. So these are just conventions. These are just what to if you get time you go through them. So that is how short is right. So the entire if statement is checking okay if the child process terminated normally. Okay, so not not I think there is something not due to a signal. All right. So these are signals like, let's say in instances like, let me explain this more because it's a very important question she's asked. Let's say if okay, the shell is running, right. When we send a signal to the shell, there is a bit of noise here. Can you guys hear me well? Hello, can you guys
Yes,
hear me
we
well?
Yes,
Yes.
yes.
So when we send a signal to the shell is a running instance of the program. So it's a process. When we send a signal to the shell like a control, when we type exit, one signal is what exit, or let's say when we press control plus D, the process just what stops. We can equally say that what it was interrupted or it stopped successfully. It is not running again, right? So then that is why we need this to indicate that the signals to indicate that what it did not end because of a signal, right? It's basically like um it did not end right because of a signal. It ended because it was what interrupted. I don't know if that makes sense as of now. Please, do you understand this line of code like now? Do you understand what it is doing now? Hello?
Yes.
Yes, so basically, yes. So if both conditions are true, it means the child process exited without an error. So if this condition is true, if both of them are true, then it means the child process exited without an error. And that means we'll know where to what. If it's not true and this print is exited without an error, we'll know where to track out our error and go and find. So basically, that is all the time. That is 48 minutes. So we spent a lot of time. We can equally say that that is all for now. And then what we are going to do now is that this is just an implementation of what this. All right, handling the user input, reading and executing the command. So in our next class or POD section, this is what we are going to try to handle.
Sorry, you have not answered my question. Sorry.
Hello.
I said, sorry, you have not answered my question. I dropped in the chat.
Oh, okay, okay, okay. Your question, yes, yes. Don't worry, we are not going. So your question was, if I'm taking, okay, yes, 75 lines. That is a good question. This is a question for Betty. Why is our code exceeding 70 lines? So yes, actually, it is like that. Don't worry, you not get an error, or we'll get an error. So we will not get an error. Don't worry. Let me check. Right, Betty, because when why can't I? I'm not even supposed to say this. When you get an error, oh, I don't even have Betty installed, right? In the main function, right? We wrote a line of code. I think my partner, we wrote about more than, I don't know. It was a lot. It was like 200 and something. But Betty did not have any problem with this one, right? And then I think the problem you are possible to face is what is when you call a function, all right? And let's say in the function implementation, the definition, the implementation of the function exceeds 70 lines. I think this is what you're going to have a problem with. But then don't worry about this. We are not going to get any error here. But don't worry, when we use the ALS test suite on it, that is when we are going to find the errors and we are going
Yeah.
to solve them.
Hello.
Hello?
Yeah, I would like to touch on the question that he asked, if it's okay.
All right, sure. Hello?
Um, so typically, see, the definition of a function is to perform just one task. A function, in the normal sense, is not supposed to perform one or more tasks. So let's say if the function is looking for even numbers, it is looking for even numbers alone. It is not doing any other thing attached to it. So
I think her network, her network.
that is the only task that the function should do. And so we are not expecting that for a function that is doing just one task, your code should be more than 75 lines. So if you ever come across this warning or error, you should revise your function again. Probably you are doing more than one thing in there. So you can like split it into two, so that the several things that are happening in there, you put them into smaller functions. Then doing that, your the number of lines of the functions will reduce. Yeah, that's what I have to say.
Okay, thank you very much. So yes, basically this is our function what definition. And as you can see, our function definition is not having any what, it's not exceeding 75 lines. But in the main, that we are exceeding the 70 lines. And then I was trying to say that yes, so we will not have any problem with what I mean. Don't worry. And then if we do, we are here to solve it. So don't worry, when we try to get the ALS test, so that will be the next section because time is fast spent. We are going to check with the we are going to check Betty and the ALS test and everything and then implement the others. So for now, don't worry about it, okay? So one, as she said, one thing is you can just this code, okay? This is what we could have done. You can, if you want, if you think that they are too much for you, you can decrease them, okay? And then I don't know, time is fast spent. I would have explained how you can just get some parts of your codes in another file. You can equally just get everything here in another file, right? And then call for the function inside it. So basically, you know what you're doing. So let's say you can write something like we are in the parent process, and then you put a function here, and the function you wrote contains these codes. Then you call for it here. That also works for you to be able to split your codes into different files, but just that you have to return void, right? And then sometimes you return based on what you are expecting. Like you want to string compare, you want to return that particular string. So basically, yes, but don't worry, our main file is safe now. So if there is any function implementation, like let's say in our main function, we are good to go. But if there is any function, like let's say implementation of a function, and then it exceeded the 75 lines or the 70 line, that's when you would have been worried. So for now, don't worry, okay? Are you okay now? Let's in your main, okay, in your main, check Betty for it. If I don't, I was trying to do it, I don't have Betty installed. So don't worry, okay? It's your question answered. Are you okay now? Does it make sense? Hello? Okay. So I'll take that as a yes. So let's run our program.
Yes, yes, thank you.
You're welcome. So wow, our program executed successfully without any errors. Like we're able to compile it without errors. Right, right. So we can assume that for now we don't have any bugs before runtime. So let's try and run our program. So before the meeting ends, let's run our program. So yes, it's printing the prompt we gave to it, right? So let's give it an input to take. Let's say user enters what ls. And it says what? It says command not found, no search file or directory. Right, that is what our program is trying to tell us. So when the user enters a command, let's use bin ls. It says command not found, no search file or directory. So guys, what's up? And they say child process exited with non-zero status 1. Right. So the fact that the child process is exiting with a non-zero status, what does it mean? If the child process exits with a non-zero status, what does it mean? Hello, guys. Hello, guys.
It was not
It means they're successful.
Hi.
It means the process was successful.
It means the process was successful. Right, right. So it means that the process was successful. Right, guys, do you all agree? Yes. Basically, it means that the process was successful. So then, why was what? Our program not executed? Guys, let's find out. Where do you think the fault will be from? Command not found. It says command not found. No search file or directory. But you and I know that what ls is a file, right? And then there is a directory also called bin ls, which we run here. And then it's telling us that it cannot be found. So where you wrote our get path, right? The only time it's supposed to say no search for directory, right, is when it does not find the program, and then it prints that error. Where was it? Where was it? So this can mean a lot of things. That either our file is not what, if it's not executable, right? If it is not executable, you can have that error. But in order for us to check if our function is working well, we can do something. We can print the path that we tokenize. We can print to see if we are getting what our path correct, so that we know that what the problem is not what from our path. So I want us to do something here. This is how you use printf to debug. Before you tokenize, what is wrong?
You have deleted the parentheses.
Thank you. Let me fix it back. Where was it? Oh, really?
Done.
It's done. Good. So let's use printf to find out why our code is not running. Bugs is what is time to tell you that it's a display, a message to tell you that what there is more to learn. So good. So in order for so there are a lot of ways we can solve this bug. First of all, we can check if what our function is working correctly and returning what it's supposed to return. It is returning what full path if the path is what. So it can mean two things. Either it can mean either what the file is not hey time is almost executable, right? Or either either the file is not executable, either the path, let me just say the path is not executable, or the file was not found, right? I think these are the basically the two conclusions I can make from this error, right? So let's try to solve one. In order to get one, let's see if what the file was found. Let's check if our file was found. So the reason why I added either the path is not executable is because you wrote a statement that it should only work if what the path or the full path is what equal to zero, which means it is what executable basically. So I realized, so yes, so let me let's print it so that everyone sees what is happening here. So we have to go to our function declaration, which we already are. This is the function we use to search, right? And then we would want to print right before the tokenization, or where should our printf statement go, guys? When should we print? Hello? We want to check if the path, we're able to find the path, right? So and then we're able to tokenize it. We want to check for me if we're able to find the path and tokenize it. So where do you think our print f statement will go for us to be able to see that? Okay, no one.
Can you repeat the question again?
Okay, so this is what we want to do. Okay, so after we how do I say it? After we run the program, okay, it's saying that command not found, right? And we understand that what can lead to some of the things that can lead to these errors is what is either the file is not executable or what, or the file it was not found. And we are trying to debug this file not found, right? So we want to confirm if we actually found our file. We want to confirm if our file was what was found. So we want to print the contents, whatever that is in what is in full path, so that we can check if it's true. Whatever that is in full path is what is actually the path we are looking for. Please, that's
Is
the
it just below? Can we do that below line number 20?
line number 20. Okay, so this is what we want to do. We want to print if we want to print our full path, right? How should we even print it? Can you come up with something for us to use? Something for us to be able to easily see or tell, something like that. Something like that. Hello.
Hello.
Yeah. So what should we print?
I think you can just type something like the full part is, I don't know, percent S or
Percent S. So yes. So let's say the full part is full part. Why is this thing? Full part is percent S. And then what do we pass to it?
it should be full part.
Full part. Good. So we want to confirm. So now let's run this program and let's see if we're able to get our full part. Thank you guys. Thank you very much. So LS. Okay. So we have our full part here. I don't know if let me clear the screen and then run it again. So after running ls, we get our full part. So it means it means that what can we say, guys? Can we cancel out this? Can we cancel out this and say that what the files were found?
Yes.
You can say the files were found. So does it mean that the files were not executable? What could be the problem? Why is it saying command not found? Are the files not executable? Because we wrote a statement that okay, if access full path is executable. So this is what we are going to do. We are going to comment this out. This is my way of for thinking we can solve what the error. We are going to comment this. No, let me not just comment it out. Let me try and return without a statement. So we would want to first of all we would not want to check if what the file is executable. So let's comment this out. And then that means all this becomes what? Invalid. So let's comment this out. So let me use the right commenting so we don't have any problem. Do you guys realize there was one thing we could have used to check if what actually that was what I was expecting but didn't get. We could have used to check if our files exist or our files were found. We could have used the last session you talked about f underscore OK.
Yes. Okay.
Yes, we could have used that to check if our files were actually what found. Hey, what am I doing wrong? What am I not doing right? I want to. Can we get rid of this statement to check for so let's return full path here. Okay. I don't want to mess with our code. Let me push it so that if we mess with it, we can pull. So basically, let's just add um what are we working on? Get path. Or let's just add everything. Just commit. It's not easy. Oh. So
We
files
have an error,
where do we have the error?
semicolon in the printer.
Um
Printf full path is line 22.
okay, thank you very much. Files were not found. So let's let me add it again. Just add okay. So we want to say commit files files were not found in their ways. Let me just push it. So now let's solve the second problem we think might be what wrong with our codes, right? So let's remove this. Let's try and return this full path without checking for anything. So our function will return what? First of all, our function will return full path. So yes, I think this one even solves it. Either ways, we are still returning full path. Even if it's not executable, we still want to return full path, right? Why am I getting this? Why is full path not defined? Okay, so I defined it here. Oh, okay. That is if the directory is not now. Or directory is not now. Full path. Let me try and bring it out. So yes. Wait, what is this? Are we good to go? Yes. Let's try it again and see. Let me clear the screen. Guys, so this is the debugging section. The reason the bug I was having in the morning. So let's brainstorm together and let's fix this. So ls, okay, double free. Let me remove one free part, copy. Let me remove this. Okay, why am I still getting double free?
You are yet to compile.
Oh, I think I've compiled. Yes, I've compiled. I've compiled. Let's see.
You have two free.
Is it? Please, you said? So,
Okay, I can see you have two free. The first one inside the if access and the other one outside the while statement.
yeah, part free. This is to free full part. And then let's just get our back solved and care about the freeing the memory allocation later. So we are not freeing this, but this is necessary to free. So let's try it again. Thank you very much. Okay, fail to execute the program. Bad address. Yes. So it means that we found what is wrong with our code. True or false? It's because so it is probably from what the exec v, and what is it? We are giving it a bad address. So yes, wow. So yes, I actually found a problem to our codes, and this is the bug I was trying to solve in the morning before I I joined the meeting. So this is the problem. So please, I hope you guys understand what is happening here. The reason we are getting the failed to execute a program bad address. I hope everyone understands. So for now, let me just pull. Let me
What
just
does that mean?
please. You said
What does that mean?
I want someone to tell us what do you guys think. So before that, okay. So I'm coming. Before that, let me say this. So this is what this is the third. No, let me not just say it. Okay, so this brings us to the end of what of today's section. So on Wednesday, oh sorry, the next time you are going to meet, this is what you are going to do. We are going to what? We are going to, by the time you come back, we would have already solved the bug. So please, all of you should go and solve your bugs. So we have solved the bugs, and then we are going to use the ALS test suite and handle special cases like if it is an inbuilt command and if it's a signal. So thank you very much for your time.